Hello and welcome! Today, we're diving deep into containerization with Docker, a critical skill for any modern software engineer, especially when building complex AI applications. We'll explore how to package your AI services into portable, self-contained units, making deployments smoother and more reliable. By the end of this lesson, you'll have a solid grasp of why containers are so vital in production and how to implement them effectively. Our journey will cover several key areas. First, you'll understand container fundamentals and their importance in AI production. Then, we'll move into the practical aspect. You'll learn to create Docker files for multi-service applications. We'll also explore container networking, volume management, and optimization strategies to build efficient systems. Finally, you'll be able to apply production patterns for robust, scalable containerized systems, ensuring your applications are ready for the real world. Let's get started. Have you ever experienced the classic "works on my machine" dilemma? That frustrating moment when code runs perfectly on your development setup but breaks in production. Containers are the ultimate solution to this, packaging your application with its exact runtime environment, dependencies and all. For AI systems, which often involve complex dependencies and heavy resource usage, this consistency is a game changer. First, containerization ensures consistent deployments across development, staging, and production environments. This means what you test is precisely what you deploy, drastically reducing unexpected issues. Second, it provides resource isolation, preventing one service from hogging resources or crashing others. Imagine your recommendation engine operating independently, even if another component experiences issues. Third, containers enable horizontal scaling by allowing you to spin up identical instances of your service to handle increased load, effortlessly managing millions of requests. And finally, they facilitate quick rollbacks to stable versions if a new deployment introduces bugs, minimizing downtime and risk. These benefits are crucial for maintaining reliable, high-performing AI applications. Let's look at how these concepts apply to our AI quiz platform. Our application is a perfect example of a multi-service architecture broken down into 4 distinct containers. We have a front-end container for the user interface, a back-end API container handling quiz logic and AI integration, a PostgreSQL database container for data storage, and a Redis cache container for session data and leaderboards. Each of these lives in its own isolated environment. Now, let's clarify some core Docker concepts. Think of an image as a blueprint, a static snapshot of your application and its environment. A container, on the other hand, is the running instance of that blueprint. You build images once, but you can run many containers from a single image. Docker images are built in layers, where each instruction in your Dockerfile creates a new, reusable layer, which significantly optimizes build times and storage. For persistent data, like our database, we use volumes. These are separate storage mechanisms that survive container restarts. And finally, networks allow our containers to communicate securely with each other, creating a private internal channel for our services. This modular approach makes our platform robust and manageable. Building containers is one thing, but making them production-ready requires a thoughtful strategy. One powerful technique is to utilize multi-stage builds. This separates your build dependencies, like compilers, from your runtime image, resulting in significantly smaller and more secure production containers. For our multi-service platform, implementing health checks and startup ordering is crucial. For instance, our backend needs the database to be fully ready before it attempts to connect. Health checks ensure services are truly operational before traffic is routed to them. Security is paramount, especially with sensitive information. We securely manage environment secrets via variables, never baking API keys or database credentials directly into our images. This keeps our credentials out of version control and off our container images. Finally, we apply resource limits and security hardening, Limiting CPU and memory prevents a single container from monopolizing host resources, while practices like running containers as non-root users and using minimal base images significantly enhance security, making our systems resilient and reliable. We've covered a lot today, from the fundamentals to advanced production patterns. Let's quickly recap the core insights. First, remember that containerization fundamentally solves the works on my machine problem, ensuring consistent deployments across all environments and preventing countless headaches. We clarified the key concepts: images as blueprints, containers as running instances, layers for efficient builds, volumes for persistent data, and networks for secure communication. Understanding these is foundational. And we discussed how to achieve production readiness involves smart strategies like multi-stage builds, robust health checks, and crucial security measures. These are the practices that make your applications truly scalable and reliable, just like those used by major tech companies like Netflix and Spotify. Now for a quick self-assessment to solidify your understanding. How would you explain the difference between a Docker image and a container to a new team member? Take a moment to formulate your answer. If you can articulate this clearly, you're on your way to mastering containerization. Keep building, keep learning.